to tell you a little bit about Julie, and then we'll get started with the workshop. So many of you saw Julie when she visited campus last fall. She gave a great seminar for us on flipped classrooms and types of peer instruction and so on. So today we're going to follow up with a little bit of a different type of seminar on creating questions. So we actually first met Julie when she was here on campus with Eric Mazur. I guess that would have been a year and a half or 2 years ago. So before Julie came to the Mazur group, she received her doctorate in higher and post-secondary education at Columbia University, where she was studying STEM professors at large research institutions and how they change their introductory types of pedagogy in undergraduate classrooms. She then completed a 4-year postdoc with Eric Mazur at Harvard University, and that's actually where we first met Julie when Eric visited campus. And then she came back to visit us again after she assumed her current position at the University of Texas at Austin Center for Teaching and Learning. So at UT Austin, Julie is currently the director of the On-Ramps program and strategic initiatives for the university, but she's also appointed as a clinical assistant professor in the Department of Education at UT Austin. And so I was talking with Julie earlier that she's back in the classroom this semester, and the challenges associated with being back in the classroom after changing your pedagogy in a large way, so we all know about that. So Julie is a nationally and internationally recognized expert on flipped pedagogy, peer instruction, and other types of pedagogical innovation. And she actually just recently, this year, received an award from the Teachers College at Columbia University. She was named an early riser in higher education for her contributions to the field. So I hope you all can join me in welcoming Julie.
Thank you so much. I'm really excited to be here again. And the basic idea of thermal expansion, when we're going to talk about metals. And the basic idea with thermal expansion is that when you heat metals up, they expand. Okay, that's the basic idea. And why do we care? Why do we care? Well, in real life or real world applications, we care because if we don't pay attention to thermal expansion, then things like this can happen. Okay, and one way to think about this is on the East Coast, where I used to live, we ride trains a lot. And when you're riding a train, if you can remember the last time you rode a train, you probably heard click, click, click. That's the track accommodating for thermal expansion. So in this case, the engineers forgot to didn't think about accounting for thermal expansion. And when it got really hot outside, the track expanded because when you heat metals up, they expand. That's the basic concept. When you heat metals up, they expand. Okay? So if you have a piece of paper, if you don't have a piece of paper, just jot it down on your notebook. If I heat up a metal, okay, if I heat up a metal, what will happen? Just jot it down. Okay. So what we just did is the kind of experience that kids have gone through for the past probably 18 years of their life before they get to you, which is typically when we ask questions to students, typically those questions are sort of recall questions where we tell and we ask them to respond back. Now I'm going to give you a different kind of question to respond to that tests the same concept. The basic idea also with thermal expansion is that metal atoms, when they're cold and they're not hot, they're moving very slowly like this, okay? When you heat them up, they don't want to be close to one another. They want to move apart, okay? If they're close, they want to be apart when they're really hot. And that's kind of what a measure of temperature is the vibrations between those atoms in the metal, okay? So let's do another question now. Now, I want you to think about this on your own and don't talk to your neighbor. The most fascinating aspect of this question is that you can hear misconceptions. When you hear those misconceptions, then you can address them. Okay, so for example, and this happens in every place that I do this, so I'm not calling anyone out here, but there's a conception that metal behaves the same way that flour behaves. So people say, well, when you cook, when you bake a bagel, what happens? The hole gets smaller, right? So people try to apply their understanding of how how flour behaves to how metals behave, okay? So it's really interesting to ask these kinds of questions where you can elicit students' misconceptions so that you can truly address their understanding, their conceptual understanding, okay? So I really like to use this question. Because I think it demonstrates a lot of the features of great question design that we're going to be talking about today. And one thing I want to also point out is that this is a multiple choice question, okay? But it's still a great question. So a lot of people disparage multiple choice questions. It's not multiple choice questions that are bad inherently. It's the distractors that are usually bad because they're not based on true misconceptions that students have. So I just want you to kind of feel the difference. So one thing that Eric doesn't do is he doesn't generally ask that first question. So that first question I asked you, I told you, and just asked you to repeat back to me. I kind of want you just to feel for yourself as we move throughout the workshop the differences between those two questions. Okay, and think about the difference in your understanding of the concept between just repeating back to me what I told you and then having to apply it in a context that you hadn't seen before for most of you. Okay?
I hate to bring this up, but
sure.
After Eric Mazur was here and we had this, and I thought about this question, it occurred to me that I still remember the answer.
Right.
I don't think I understand anything because of it. And I think I understood the concept of expansion in one sense, and I still understand it in exactly the same way. And my question that I still have with that hole in the center is, I don't know what geometry of the molecules maximizes their distance.
Sure.
And that's really the question that you're asking, and I don't really know that, and I still don't understand that. And so I'm not sure that I feel that this has been a truly useful, for me, way of understanding anything about this.
Can you remind me of your name?
Max.
Max, okay. So I think this is a good point. So Max is saying that he still doesn't understand the concept, okay? The reason probably is because this is not a class on thermal expansion. So if this was a class on thermal expansion, we would have done a reading beforehand, or we would have done some kind of video beforehand. We would have spent a significant amount of time beyond 1 minute lecturing on the concept. We would have done homework problems. There would have been opportunities for significant interaction with peers and neighbors. And there would have been more formal assessments. So I think the point of this question and why I use it is not to help you deeply understand thermal expansion. The point of the question as I use it is to show the difference between a question where you have to apply your understanding in one context to a question where you simply have to repeat the understanding. Part of that probably also comes from that I'm not a physicist or a chemist, so I can't go as deep as Max is asking. I always get a chemist who says, but the chemical bonds fold, and that's probably true. I'm not sure. But I want to acknowledge the fact that this is not, the purpose of this question is not to provide you a deep understanding of thermal expansion. The purpose is to demonstrate the differences between the two questions.
So you're not going to tell us what the bagel hole closes up?
Why I don't know how flour behaves. I don't know the principles of flour. I don't know the principles of flour. Another misconception that comes up a lot with this question, another misconception that comes up is that the atoms behave differently around the center of the hole than they do in the rest of the metal. Okay, so you can really, for me, what I like about this question is that everybody wants to try, everybody feels like they can answer it. Okay, so everybody tries. Okay, and then when you go around the room, you see people interacting, and I'm going to make a point about why that is as we navigate throughout the presentation. But thank you for the question. I think that's a great point. Okay, so what we're going to do today is we're going to talk about one big idea about question design. We're going to go through the anatomy of a question. We're going to talk about some design considerations, And we're going to spend the rest of our time together doing a question analysis and then writing some questions. So let's talk about the big idea. So those of you who were part of the presentation when I was here last time heard me talk a lot about the importance of having students think about things if you want them to learn them and you want to remember them. And the big idea really behind what I want to talk about today is that learning is the residue of thought. So if you want students to learn something, and you want students to remember what they've learned, they have to think about it. They have to think about it. So some of you who did that question before and then did it again today and didn't remember the right answer is probably because you haven't thought about it in 2 years. Okay? So learning is the residue of thought. If you want students to remember and to learn, they have to think about the content that you want them to remember or learn. The biggest idea, however, that I want you to come away with is that questions direct thinking. Questions direct thinking. If you want someone to think about something, then ask them a question about it. Okay? We can direct our students. In fact, assessment is one of the most powerful tools that we have to direct our students to think about the things that we want them to think about. Okay? With that first question, if I wanted students simply to remember the fact that metals expand when you heat them up, I could use that first question to direct their thinking to just memorization. But it's unlikely that they would remember it over time. I'd have to do a couple different things to get them to remember it. Okay, but if I want them to have a little bit of a deeper understanding of the concept and push them to a little bit higher level of cognition, then I want to ask more of an application type question. We're going to dig into that a little bit deeper. But this is the biggest idea that I want you to come away with. If you want someone to think about something, ask them a question, and questions direct thinking. Okay? So I had asked you this question before. What is the secret to good question design? So those of you who heard me talk before probably heard me talk a little bit about Goldilocks. Did I talk about Goldilocks before? Okay, so Goldilocks is the key to good question design. Does that surprise you? So that's another trick there, right? I'm using something that I'm using your prior knowledge of something to make a point. Okay, the Goldilocks range of desirable difficulty. How does Goldilocks like her porridge? Just right, not too and not too cold, right? How does she like her bed? Just right, not too soft, not too hard, right? So when we're writing questions, one of you put, not everyone gets the answer correct. So I would say that's pretty close to the point that I want to make, which is that the secret to good question design is that they're not too hard and they're not too easy. Okay? People are naturally curious. People are naturally curious. So they want to engage with questions. But what happens when we see a question mentally is what we do is we immediately assess how much mental work it's going to take to do that question. And if we believe that the question is extremely easy, we might answer it, but our interest is not going to be maintained over time. Okay? If a question is too hard, we immediately check out. And you probably have seen this a million times with your students. Okay? So writing questions that are at this desirable level of difficulty are really important. And we're going to talk a little bit about, hopefully by the end of this, you'll have a little bit more of a sense of that. That said, questions don't always have to be perfect. Okay? A lot of my teaching this semester, I did a lot of work with learning catalytics, and I really stressed over the questions. When you're using a question for a summative assessment, it needs to be really well thought out. But when you're just using a question to grab students' attention, or to elicit engagement, or to direct their thinking, it doesn't have to be a perfect question. okay? So those kinds of questions can be used for fun, for engagement, to solicit quick feedback, to grab someone's attention, to change the pace. You heard me talk about last time relieving you of the pressure of having to make your subject matter relatable to every single student in your classroom, which is impossible. All you have to do to get somebody's attention is to change the pace. If I wanted to get your attention right now, I could just ask a question. You can just ask a quick poll question. It doesn't have to be a perfectly designed question. The questions that really need the most amount of thought and care are your end of, your summative assessments, because that's something that really makes a difference and counts for students, okay? But the big idea is that questions direct thinking, and we want to direct our students' thinking appropriately. What kind of thinking should we direct? Well, I like to use Bloom's revised taxonomy to help me figure out what kinds of thinking that I want to direct for my students. And I've listed here Bloom's taxonomy, the revised taxonomy, based on Bloom's order of cognitive skill, okay? So the highest cognitive skill that we can engage students in is creation. And that's asking if students can put together learning in new and innovative ways. Evaluation, can they make judgments and support their positions? Analysis, can the student discern similarities, differences, in how knowledge is connected or organized? Application, can the student apply what is learned in a new or unfamiliar context? Can the student make meaning or explain what is learned? And can they remember? Can they study or recall what is learned? Just because recollection and understanding are the lower order does not mean they're not important. In fact, one of the things that you can do to create questions that are at a level of desirable difficulty is to shore up students' prior knowledge. So one of you wrote that on what makes a good question. You wrote scaffolding. So one of the number one things that you can do to write questions at a level of desirable difficulty so that they're not too hard is to ensure that students have the prior knowledge that they need in order to answer the question. So I like to make a little revision to Bloom's. I think they've got apply too low. To me, application is the core purpose of education. So I think that one's at a higher level. In addition, it's exceptionally hard for students to apply their knowledge into new contexts. And that's because they view, and often their learning is situated by the classroom that they're in, by topic, by the bounds of the classroom walls, and also the topic that they're studying, even by chapter, sometimes just by concept, okay? So their learning is typically situated, and they don't get a lot of practice applying it outside, but that's what we really want. That's the core purpose of what we do. That's usually what gets us up in the morning, is that they can take what they've learned in our class or what we've taught them and apply it outside. So I elevate application at a much higher level. So that's another way to write questions at a level of desirable difficulty. I talked about a way to make sure that the questions aren't too hard, are easy enough, right? How do you make sure that they're not too easy? Application questions are traditionally exceptionally hard for students. They find it very difficult to transfer their knowledge. There's two strategies to help students transfer their learning across contexts that I love. So when you're preparing questions that you want to give students lots of practice, you really want to give students a lot of practice doing this, there's two strategies that I like to use. The first one is called hugging, okay? Hugging is the first strategy for helping students transfer their knowledge across contexts. So hugging refers to near transfer. Okay, so that means that the contexts are really similar. In hugging, the contexts are really similar. That's all that means, is near transfer. So they have to take something that they've learned and apply it in a context that's similar but different. Okay, so I would qualify this first question that we did as a near transfer question. Okay, we're talking about the same concept. We're talking about metals. All we've done is we've put a hole in the plate. Okay, if you took the hole out and you just asked them what's going to happen to this plate if you heat it up, that'd be super near transfer. That'd be super hugging. We're just doing something that's very similar here. It's not a completely foreign context. Okay, so that's what hugging is. The ultimate goal, though, is to have them bridge their learning across really unfamiliar contexts. And that's called far transfer. And the best way that I can explain this is to talk about Daniel-san in The Karate Kid. Okay, so in The Karate Kid, what does Mr. Miyagi make Daniel-san do? What's the famous phrase? He was waxing his car, right? He also he paints the fence, right? He paints the fence. And what does Daniel-san think of this? Stupid. What does he say? What's the point? Why am I doing this? He doesn't get it, right? But then when he gets to understanding, it all becomes clear. But those are radically different contexts, okay? Waxing the car and painting the house are radically different from blocking in a karate tournament, okay? So that's an example of bridging. That's an example of bridging. There's gonna be some examples of bridging when we go through our exercise in just a bit. Okay, just quickly, I always find it interesting. I find the anatomy of a question interesting. It's something that, as an educator, I never learned the anatomy of a question. So I always find it interesting to kind of just go through the anatomy of a question. So there's 3 different question types primarily. The first is a multiple choice question. So what's the answer to this question? 1 for A, 2 for B, 3 for C, and 4 for D. Just go ahead and hold it here. Hold it here. Lots of right answers here. Okay, great. Okay, so there's no point to that question. That's just an example of how it doesn't have to be a perfect question, but you can get engagement and change people's. Yes, it's a Basenji. Probably you remember that from last time because I have one. All that, the multiple choice questions test a certain kind of mental activity. Okay, the power of a question to memory, is phenomenal. When we retrieve information from our minds, it writes on our memories. That action is called retrieval practice. So if you want someone to remember something, you give them a test. Okay, students don't know this. They think that reviewing is the best way to remember something. That's the best way to remember something for the next day. Long-term retention is facilitated by frequent quizzing of yourself. This requires recognition retrieval. All you have to do is recognize the right answer. You don't actually have to find the right answer in your mind. You just have to recognize it. Constructed response is different. Who knows the answer to this one? I hear little whispers. Portuguese water dog. Portuguese water dog. Okay, so you feel the difference, those of you who answered both of those questions, the difference between having to recognize a response and generate the response yourself. Okay, so with a constructed response question, that's a different mental effort. It's a different kind of thinking. That requires effortful retrieval. You have to generate the response yourself. The third question type is a modified multiple choice. So I'm going to ask you to just think about the answer to this question. and kind of hold it in your minds for a moment. So what's the answer on this one? 3, right, Weimaraner. Okay, so that's a modified multiple choice question. That's when you have them generate the response first, and then you provide, so you have effortful retrieval first, and then you provide recognition retrieval second. Okay, I'll talk a little bit about when to use these different types of questions in a minute. This whole thing here is called an item. This whole box, the whole question is called an item. So when we're talking about question anatomy, this is an item. This first part here is the question stem. And the question stem has this first aspect of it, think about all the dog breeds we studied this semester. And this particular point where you're asking the student to make a response is the prompt. And these are the options. This is the answer. And these are the distractors. So that's the basic anatomy of a question. When we're preparing questions, if we're doing multiple choice, the key to writing a good multiple choice question is to make plausible distractors. One of the best ways to do that is to, in your first semester, ask open-ended questions. All you need to do is do that once in a class of 20, and you'll get all the distractors you need for the subsequent semesters. So when should you use these different types of questions? The modified multiple choice, and constructed response. For multiple choice, those are best when the response universe is known or to get quick engagement through a poll. Constructed response is best when it's hard to anticipate what the student's responses are going to be. And modified multiple choice is great when memory is critical. And those are better for formative assessment because they're hard to do. A modified multiple choice is hard to do on a written exam. Okay, you could do it with clickers or with a system like Learning Catalytics, but it's hard to do on a written exam. But that is a great tool because it's got that double retrieval practice when memory and retention and recall is really, really important. And remember the point that I made that a lot of people disparage factual knowledge, right? And they disparage recall. I did it a little bit at the beginning. But the reality is that prior knowledge is the number one predictor of success in an academic environment. Okay, so giving students opportunities to shore up their prior knowledge is really important. And like I said, I think that's the number one tool to writing desirably difficult questions is to make sure that they have enough prior knowledge to engage with the question. Okay, let's talk about different question types. Like I said, there's multiple choice or constructed response, but there's also a bunch of different types of questions, and I'm going to give you a list. Learning Catalytics, for example, does a wide array of question types. It does composite sketches. So if you are in a course where students need to do a lot of graphing, it takes all of the students' graphs and lays them on top of one another as if it's a transparent sheet that you're stacking all of their graphs on top of one another. It does numerical. It does directional questions, region questions, short or highlighting questions, word clouds, image uploads. So if you're teaching a class or a lab and you want to have students, for example, you're teaching a lab and setup is really important or safety is really important, you could ask them to take a photo of their setup and send it as an answer to one of your questions. So it does image upload. There are 18 different question formats. that you can pose with learning catalytics, but I think you can use these different question formats no matter what system you're using. It's just that learning catalytics will automatically score some of them for you. So the question is, to what extent should a distractor be sort of a trap for a common misunderstanding versus misconception? So I tend to err on the side of my goal is not to trap students into selecting an incorrect answer or to try not to trick them. What I try to do when I'm preparing distractors is really write plausible misconceptions, okay? It depends on what the purpose of your question is, okay? So if the purpose of your question is to help the students learn versus a formal assessment question, I would steer away from trying to write tricky. Does anybody else have a opinion on different distractor types that they'd like to share? Okay, so one of the things that I said shoring up students' prior knowledge makes things so that they're not too difficult. I said application questions can make things more difficult. Okay, there's another strategy that you want to think about when you're writing questions to try to make them at a range in the Goldilocks range, and that's to try to reduce students' cognitive load. Okay, what is a cognitive load? Cognitive load is the demand that we are putting on our working memory. Our working memory only has a limited amount of space. Okay, and our working memory is our conscious awareness. That's what we're in right now. If I say polar bear, I've now all enacted your long-term memory. Okay, that's something that's now it's in your working memory, but I enacted your long-term memory to pull it out. Okay, but working memory is the site of conscious awareness. Our working memory has only a finite amount of space. Our long-term memory has an infinite amount of space, but our working memory only has a finite amount of space. Okay, and there's nothing we can do to make it bigger or smaller. It's just what it is. When you're writing questions, you want to make sure that you don't have extraneous information that's increasing students' cognitive load, right? A lot of times what happens with questions and the reason students check out of questions is that it doesn't respect their cognitive limits or they have cognitive overload. Now, there are things that are germane, okay? There's called germane cognitive load. That's when you want to, when the details that are causing the overload are important to the learning. So maybe that shape question is essential, it's germane to the learning, it's germane to the learning outcome that you want to accomplish. So then I think it's okay to leave that in. But if it's extraneous to the learning, then you want to sort of cut that out. So the task is up to you to determine what is germane to my learning outcome and what is extraneous to my learning outcome, and figure out which to leave out and which to keep in. So that's a little sort of, I've got another question in the back there.
Yeah, so like for instance, in some of my chemistry exams, I have them do not multiple choice questions, but actually have to do calculations.
Yep.
And so sometimes in the word problems, I will put in some extraneous information that looks like they ought to use it, but they don't need to use it.
So if that's...
Is there anything wrong with that?
So I would have to really look at the questions and have a better sense of that to give you a yes or no on that. Yeah. But if what you're trying to do is teach students how to focus on what's important and leave out what's not important when they're doing, that's a key skill of problem solving, then I think that it's appropriate. It depends on what your purpose is. Okay? The other thing I'll say to that, though, is that they need practice doing that. Okay? So I think that the key to preparing students to succeed in that kind of situation is to shore them up with practice. Okay, so here are things that cause students to have cognitive overload, and then I'm going to have to move on, or we're not going to get to we're not going to get to the workshop aspect of this. But questions with multiple steps, questions with missing variables, questions with questions that require multiple chains of logic, and questions that require students to apply their knowledge in new or different contexts. Those things cause cognitive overload. I think it's absolutely ridiculous to say you're never going to ask those types of questions, because in fact, the problems of the 21st century have all of those features. Okay, but what you need to do is prepare them to be able to answer those kinds of questions. And the best way to do that is through scaffolding. Okay, what is scaffolding? All scaffolding is to provide instructional supports at the beginning of learning and then remove those supports later in the learning after some mastery and practice has already developed. Okay, so I'm gonna be around for lunch, so I'm happy to continue our conversation about distractors, but I definitely want to make sure we get to the workshop component.